Okay, good morning. So I think we start from page somewhere 81 or 82. Let me see. I think I got some idea. I think we have done up to here. Am I right? I think we are.
Okay, good morning. So
Yes.
I think we start from page.
Okay, we have done up to here, right? This is page 81. So we continue. Next section, which is length, volume, and area elements. In this section, we are interested in finding the material derivatives of elements of arc length, area, and volume. I think we have done this one. Okay. Uh, so we just consider small x as a function of large X, or this is the position of particle. This is a particle. Position of particle in spatial coordinate, right? So then this is an element of F. This is called F alpha I. Okay. Then, so we end up with taking a derivative on xi. So we have this result, right? Then I don't get this idea yet much. We remove partial alpha. It's kind of strange. We remove partial alpha. Then we put D. So I have some hard time, filling this gap. But I decided to compromise. Okay, we just accept. I don't get this derivation, but we have to accept to move ahead. Then this is a famous identity. See, you have I is repeated, right? So you have partial x alpha, partial small xi, and you have partial small xi, you have partial large x beta. This is partial x alpha, partial x beta, and these are orthogonal, partial alpha, partial, I don't know, x alpha, x beta, x gamma. These are orthogonal. So it is 0. This is delta. This one is delta alpha beta. Because three axes are orthogonal. So then, let me see, next page, we get this. So we now take derivative of this. This is, you take, I think you know this derivative, ddt. I'm not particularly sure why they use large D here. I don't know the difference between this and this. But anyway, so if you have some product and want to take derivative, you just do the first derivative and second, and you leave the first and you take derivative of second. Yeah. So this formula was used and we obtained this. Then you can see this here we used the previous relation. So x was changed to v, right? For some reason, J and I are mixed. So strange. Is this the typo? I'm not so sure if whether this is a typo or something. So if you follow this carefully, what we should obtain is xi is changed to vi, and what else? See, J. Do we use something before? So this part is a problem. I didn't get this part. What is this? We have J. This is more like we change, right? We have to change partial x alpha. This one we should change to partial xi, partial x alpha, partial xi. I'm sorry, I have to put it here. This one partial x alpha. So we have to replace this. So we use j instead of I. So we have j here. So we have this guy is here, and this guy is here. Because we have v here, we put v here, vi, so vi. So this is the trick. So let's see. Here we obtain, first of all, this was changed. This one is actually partial beta vi. Yeah, and this is equal partial beta the partial beta we have to change to like this. Partial j, yeah, we have to change partial j x alpha, partial alpha vi. Is this strange? Let me see. Partial beta is partial x beta. This is like this partial partial xj, partial x beta, partial xj. Because j hasn't been used, so we have partial. Here we have partial. Let me see. This one goes like this. Partial beta xj, then partial j vi. Okay, this is the thing. So you see, so this thing go like this. So this is exactly like here. You can see partial beta xj. Here I is used instead of j. That's the confusing part. I think this is typo. I would say this is typo. So j should be I. J should be I should be j. So let me change color. Alpha partial beta xj. Okay, here another thing. I should be j, I think. Yeah. So we see partial beta xj is here. Partial beta xj. Yeah. So then we have, let me see, another color. Partial jvi, partial jvi, like here. Then you have even another color, maybe this one. This one in front, you have in front, factor in front. So it makes sense, I think. Then, what is the thing? J, I, how was it this? Okay. Beta xi. So this division is a little bit strange. See, I don't get this division part much clear because this I is a summation. I is a summation for summation, right? So then how can you? Then this is not. This is very strange. See, I should rewrite this maybe. So let me rewrite it. Partial beta xi, partial beta x small xi, right? ddt partial I x alpha, partial I x alpha equal minus partial I x alpha minus partial I x alpha partial j vi partial j vi then partial beta xj. Why do I have I here? Partial beta xj. Then this author want to eliminate this one, right? They want to take this out. The question is how you take this out. It's a big question. See, I is summation. I is for summation, right? See, this I is summation. Then what he say is this thing. Nonsense. I vj partial v partial I vj partial I vj. It's not even I. And partial j x alpha. I don't know why this you can see first I is changed to j here. Yeah, I is changed to j. J is changed to I. Alpha is the same. But then this was removed. This is gone. So I just have big question mark here. I cannot follow the step. I'm sorry. I think I have to give up. I cannot follow this step. But what they say, I think that what they say is two things or three things. JVI partial alpha xj. See, let me see. What they say is this. So if this kind of textbook, if something is not clear, it takes a long time to understand. It's a big problem. See, I can summarize what they say. DDT equal partial JVI partial JVI partial alpha xj partial alpha xj. This is what they say first. Then second is this. DDT, so this is xi. dd, I'm sorry, this is not xi. This is d dt partial, I forgot. I'm sorry, I forgot. Alpha xi, alpha small xi, partial alpha small xi, this is this. Okay, then d dt maybe partial I large x alpha. Is this what they say? Okay, which is minus partial I vj minus partial I vj partial j x alpha. It's quite confusing. I don't know if they have some other derivation. I think this is okay. This is okay. We understand. I just didn't understand why we have to drop. He eventually said he dropped this guy. This guy. This is very, very strange. I think he didn't drop this one is just a change to D. Then this guy is changed to D. And otherwise, these two things are same thing. Looks same. And I don't know what is the use of this equation. What is the use? Yeah, it's very strange. Then we don't use this anymore. Then we start from some identity like this. Then we make a strange deformation. Maybe one possible way is something like this. See, why don't we multiply like this? Partial j x beta. Does this work? Let me see. Partial j x beta, partial beta xi. So if we do this, partial x beta partial small xj and partial small xi partial large x beta. So this is delta ij. Yeah. So we just multiply this one. So this part become delta ij. So then you have summation on I. So I change j. This I is changed to j. Okay. So then this guy becomes j. So this works, I think. So I think this works. So we have here we have something like this. Let me try. So we multiply partial j x beta. Then sum on beta. On beta. Right? So we have partial, j is already used. So j is already used, so we have to use k, for example. So then we have partial k x beta, right? So then this part is delta ik. So the I is changed to k. Then we can eliminate this. Then we have new summation. See, we have this summation. So this is more like delta jk. So then the j part is changed to k. So then this whole thing is deleted. Yeah. So now we change. We first want to change I to j. Here we want to change this I to j and this I to j. This is okay because this is for summation. And j is not used any other place. So then we change k to I. K to I. So then what happens? Let me see. Let me do it. So we change k to I. Right? So then we change I to j. Then we change k to I. This is I. Then we change v to vi to j. So is this the thing we had? Already delete. jx alpha. Let me see. Do I do this? Where is the minus sign? Oh, no. There is minus sign. Minus sign. Okay, let me see. Strange. Jx alpha. Last one. We look at this last equation. Ivj jx alpha. Ivj jx alpha. So I got it. I finally got it. Okay, I finally got this equation. So this is okay. Yeah. So to summarize, this is the thing. This is the thing. No. What is it? I think this is the thing. We don't have to change partial to J. So this is what we got finally as a conclusion. So now, then we go to the next length. Let me see. It seems I skipped something. Maybe okay. I didn't skip. length. So we have take a derivative of length. Then this is just this is a little bit strange. dv dx. This one I think we should do this. This equal to dxi d sorry d dt dxi. Yeah. So then this part I don't remember the formula. I think somehow this was changed to d by magic. So partial j vi, this is like this thing is partial j vi dxj dxj. So now you have dxi and dxj, but here it's changed. I and j is reversed. But I think it's okay. You can reverse I and j because I is for summation and j is also for summation. So you can change order. So we just have to accept this magic part. This partial alpha was replaced. Partial alpha was replaced to j to d. Then we can obtain this one. The velocity gradient. Velocity gradient. This is more like a definition. Velocity gradient can be solved into a symmetric and skew symmetric component as. So this one you can view as matrix or tensor. So you have 1, 2, 1, 1, 1, 2, like 1, 3, 3, 3, 3, 1, something like this. 3 by 3, 3, 2, 2, 1, 2, 2, 2, 3. Right? So you can view this as a matrix. The matrix can be decomposed into symmetric and skew symmetric, anti-symmetric part. Skew symmetric and anti-symmetric part you can decompose, right? So this D is a symmetric part. D is a symmetric. W is an anti-symmetric part, skew symmetric part. Tensor D and W are known as deformation rate and spin tensor, respectively. As dxi dxj is symmetric, we get this is interesting. Huh? How do you get symmetric? Symmetric multiply anti-symmetric, not so sure. So you can say symmetric means like A11, A22, A33, A12, A12, A13, A13, A23, A23. This is symmetric. Anti-symmetric is like 0, 0, 0, B12 minus B21, B13 minus B13, B, this is 0, sorry, B23, B23 minus. So you make, if you calculate this one, this is, do you get 0 for this? I don't get 0. And this here you have B12, A11, no, A12 plus B13, A13. So I don't get 0. I think this is not matrix multiplication. I'm sorry. This is a little bit confusing. This is not matrix multiplication. You can see because IIJJ. So you can see here. This summation contain, for example, like this, D13, dx1, dx3, and it also contain d31, dx3, dx1. Yeah, so it contains both. Then if D is anti-symmetric, D, okay, so if this is not D, if this is D, these are same. These are same, equal, right? But if this is not D but W, W is anti-symmetric. If D is not D, and if this is W, 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 ah, what am I doing? What am I doing? dx1, was I strange? Okay, let me do it again. I'm sorry. Okay, so this one, yeah. So the W part, I think you guys understand already. D is symmetric, so IJ equal minus DJI. W case, IJ, oh no, this is plus. IJ, WIJ equal minus WJI. Okay, so this is anti-symmetric. So if it is anti-symmetric, then this part is symmetric. So XI, part is symmetric. So if you take sum, you have plus and minus, so it becomes 0, right? So if Dij is symmetric, then interchanging I and J doesn't change anything, so you just get plus and plus. So you don't get 0. So you only the symmetric part remains. Yeah. So you have this. You have final conclusion of this. It's a little bit complicated. Then you have volume. So from dV equal JdV, which I think, I don't know, we did long time ago. Let me see. Where did we do it? Let me just search JdV. JdV. We did it here, right? We did it here. Change of area. We did it here. dV, d small v. Okay. So then we take time derivative of this. So because this is constant. This is a constant. So we just leave. Then this thing. How is it possible? Okay, because J is a function. J is a function of this whole thing, eh? Uh, one, 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 two, one, three, two, one, two, 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 three, three, one, 3x1, partial 3, partial x2, partial 3, x3. So, J is a function of 9 parameters, right? So we just take, so this is a J. J is a function of these 9 parameters. Okay, so then we take derivative of 9 parameter like this. So I think this is okay. So then here we use the same equation like this. Here we put partial alpha back, partial alpha, right? So alpha I is alpha j, now it's a j. For some reason this became j here. Isn't this strange? I would do this I here. Why this is j? I think I would do I. Because alpha summation, I is also summation. Partial jvi, partial jvi, partial alpha xj, partial alpha xj. So this is same. So this has to be I. I think this has to be I. So you have this. You get this. dj dt. Then this is the problem. Okay. This is cofactor. Observing that the partial derivative of j is the cofactor in the determinant expansion for j, we obtain this. This one actually I found we have done long time ago. Or we have, this was explained, maybe explained in some, seems we have done, no, this one, right? And actually I don't want to use this 5137. I don't want to use this one, but here we have something, right? IJK alpha beta gamma beta j gamma k s. So here you put j, you just move this j to here. Then this is partial j, partial f alpha I, and this is partial J, partial alpha small xi. So this is the thing. We have partial J alpha xi. This is the J. So let me write it down. Partial J, partial alpha xi equal J, let me see, J multiplied by this. Is this clear? Because see here, yeah, so this one without a J, this thing is this thing. Yeah, I think this is clear. So partial alpha small xi and partial alpha small xy is J partial I x alpha. So this one we have done. Let me say what is this? 116. I don't know. 516. Sorry. 516. This is just we obtain this from 516. Okay. So then, what is this? We take derivative of J. We use this. We use this J partial I. So we just need to write this thing is replaced to J partial I x alpha. Then you see partial alpha xj and partial I x alpha. This makes delta ij. So then we make a summation. Ji, we make summation, right? So you can sum on j or I either way. So you have j partial I vi. Okay. So then we do so this v is volume. It's not velocity. This is volume. you multiply dV. Here, see, this one is d dt dV was dj dt dV. Then this guy is j partial I Vi, but then j dV, this is small dV. So we have this partial I small vi dV. Okay. So now we go to area. So maybe let me stop this video here. So we will continue from 6 to 3 area next time.